If you search for Spring Boot JWT tutorials, you will often find they involve third-party libraries and custom filters. I have even made video like that which you can find in this channel. But here we are taking a different angle. Spring Security natively supports JWT functionality and that's what we'll use. In this video, you will learn to generate HS256 tokens in Spring Boot 3 leveraging this built-in support, authenticating users against credentials stored in the MySQL database, all without adding separate external JWT libraries. Discover a more integrated and fundamental approach to token-based security. So, let's get started. Let's create a new Spring Boot project using this online tool from start.spring.io. I am going to select Maven as the project type and the language is Java. For the Spring Boot version, at the time of this recording, the latest stable version is 3.5.0. I will use that. Now, let's add the project metadata. For the group name, this is typically your domain name in reverse order. In my case, it is com.learnwithiftekhar. For the artifact name, let's use Spring JWT demo. Then packaging. The packaging will be jar, and for Java version, the minimum required Java version for Spring Boot 3 is Java 17. I have Java 24 installed, so I'm going to select that. Make sure your installed Java version is 17 or higher. Now it's time to add the necessary dependencies. Click the Add Dependencies button from here. First, I'm going to add Spring Web. Then, to enable Spring Security to natively validate incoming JWTs and protect our API, we need to use the OAuth2 Resource Server. It relates to how Spring Security can handle JWTs. Next, we'll do some database operations. So, we need Spring Data JPA. And I'm going to use MySQL as database. So, we need the MySQL Driver. Finally, let's also add the validation dependency for any validation task. And that's all the dependencies we need for now. To generate the project, click on this Generate button. Our project is generated and downloaded as a zip file. Go ahead, extract it and open it in your favorite IDE. Here, I have opened the project in IntelliJ IDEA. Now, let's try to start the project. But before starting, here is our pom.xml file. Let's open it. And here is the list of dependencies that we have added in our project. For the time being, let me comment out this dependency, the Spring Data JPA dependency. This is because if we start the application now, it will throw an error as we have not configured any database yet. So I'm commenting this out for now so that we can check the application runs properly without it. And now we need to synchronize the Maven changes. I will click this icon here to synchronize this. And now let's start the project. So our project has started. Now if we check, let's browse the site in the browser. Let's go to localhost 8080 and here we have this login form. This is default login page provided by Spring Security. But if you remember, we have not explicitly added any Spring Security dependency. Let me show you the pom.xml again. Minimize this console. Here you can see this was our Spring Data JPA, which I have commented out previously. Let me uncomment this now as we will configure our database soon. So this was our Spring Data JPA. Then we have this Spring Boot Starter OAuth2 Resource Server. We have dependency for validation, Spring Web, and the MySQL connector. But we have not included Spring Boot Starter Security directly. How come this login page is showing? The reason is this dependency, Spring Boot Starter OAuth2 Resource Server. Let me show you the source. Let's comment and click, or if you are using Windows, Control and click on this dependency to see its pom.xml file. Here, the pom.xml file for auth2 Resource Server. If you scroll down on the dependency section, okay, here is the dependencies. You can see it includes Spring Security dependencies. So by including just the OAuth2 Resource Server dependency, we transitively get some features of Spring Security. And that's why we are seeing this beautiful login page. And we are not doing anything with this default login page for now, as we are going to implement JWT-based authentication. So we won't need that specific login page. And obviously, as we have uncommented this JPA dependency, we need to synchronize this Maven project again. First thing first, let's create a test endpoint. An endpoint that we are going to access using REST API and later secure with JWT. So in our project, under this src main java, here is our base package. Inside this base package, I am creating new package. Let's name it controller. And inside this controller package, create a new Java class. Name it, let's say, home, then controller. Mark this home controller with REST controller. And I am going to set a base endpoint request mapping, and this is /API v1. Okay. Inside I will add get mapping /hello. This will be public method that returns a string. Let's name this method hello, and this method will simply return the message hello world. Now this endpoint is currently protected by the default Spring Security setup, and we are going to implement JWT-based authentication to access this URL. Let me show you. Let's try to restart the project. Showing error. Application failed to start. That is because failed to configure a data source. That's because we have uncommented our Spring Data JPA, but we have not configured the data source details yet. Okay, let's configure it now. To configure the data source, open our application.properties file from the resources directory. And here we will provide the configuration for our MySQL database. The first one is our database URL. The property will be Spring, then data source, then URL. The value is JDBC :MySQL : // then the host, that is localhost, and the port, this is 3306 / and the schema name, let's say it is JWT. I have not created this schema yet. We'll do that now. For connecting with the database and creating this schema, you can use MySQL Workbench or command line tool. But my IntelliJ IDEA Ultimate Edition comes with this database tool. From here, I can use the IDE as my database GUI tool. So click this database icon here. From this, click the plus icon, then data source, and select MySQL. Here the name. I do not need to change anything for the host and port because it's running on my local host and default port is 3306. The username for my MySQL database is root, and here I am giving my password. Now here we need to download a missing driver file. Just click here to download that. This is for IntelliJ IDEA to communicate with the database. The IDE requires this MySQL driver. Here our driver is downloaded and I need to click the OK button. You might not see this button as this was outside my recording area. So I am clicking that OK button. So this is my localhost database connection. Currently, we do not have any schema named JWT. Let's create one. We can do this in the console that my IDE automatically opened after connecting, where we can write SQL queries if we want. But I'm not going to do that. Let's close this console. Here in the database tool, right click on this localhost connection, then new, then schema. The name of the schema is JWT and click OK. So our schema is created. Now back to our application.properties file. I did not save the properties correctly, so the previously added configuration is gone. Yeah, it happens. Let's add them again. The first one was our URL, spring.datasource.url, that is equals JDBC colon MySQL colon localhost, then the port 3306 / the schema name JWT. Then we need to add the username. So it is Spring, then data source, username. My username is root, and after we need to provide the password. It will be Spring data source password. Here I am giving the password. Now we need to provide a driver name for MySQL. Spring, then data source, then driver class name. And here we have a couple of options. I'm going to select this com.mysql.cj.jdbc driver. Now I will add some JPA or Hibernate related properties. These are the minimum configuration required for connecting with the database, but I am adding these additional properties for enabling some other features like showing the SQL queries in the console or formatting the SQL queries. So the first thing, I want to show the JPA queries in the console. Spring dot then JPA and show SQL and set it to true. Then I want this query to be formatted. Spring JPA properties, then hibernate.format SQL and set it to true. After that, I need to provide a dialect. It is Spring JPA database platform. This should be org.hibernate.dialect.mysql dialect. Remember, this database platform dialect is important. Without it, JPA might not be able to generate proper queries for the database. And the final property I need is DDL auto. Spring.jpa.hibernate and DDL auto. For DDL auto, we have a couple of options. Update, create drop, create only, drop, truncate, validate, and none. If you want to know more about these options, you can check my other video tutorial on Spring Data JPA where I explained this in detail. But for this tutorial, I am going to choose create drop. What this will do is that whenever we start the project, it will create the database tables based on the defined entities, and whenever we stop the application, it will drop these tables. Remember, this is only for testing purpose. In production server, never ever select this option. It will lead to deletion of your data, and that is for the database configuration. Now let's start the project and check if we can run this application properly. So this time our application has started. Let's check the console. Here we have this message, Tomcat started on port 8080. Okay, and if we try to access our this API endpoint, hello. Let's try to access this using Postman. Here in the Postman, let's close previously open tabs. Now open a new tab. This is get request, and the URL is localhost. Then the port is 8080/API. Then v1, and then the endpoint, that is hello, and send the request. Here you can see we have these 401 unauthorized error. So our API endpoint is protected with Spring Security. Now we'll configure our Spring Security to authenticate using JSON Web Tokens. We will generate JSON Web Token, but for this we will not add any other third-party libraries or create any custom filters like we have created in our previous tutorial. Let's start doing that. But before that, I am going to create the necessary class and structure for user sign-in request. So what I am going to do is, in our base package, I am going to create a new package, name it model. Inside this model package, I am going to create new Java class. Name this user. This is our user entity for our application. Add the entity annotation to make this a JPA entity, and also add the table annotation. With this, we can define the table name where this user will be mapped. Here, I am going to use the name user. Now, our user entity needs to have primary key. For the primary key, we need to add ID annotation, and also we need to provide how this ID will be generated. Our ID will be generated automatically by the database. So here we are going to use the generated value annotation and provide the strategy, which is generation type dot identity. This generation type dot identity will use MySQL's auto increment feature to generate the ID. Then create a private field, type long name ID. Our user will also have username and password. Let's define those fields. Username, and again private string password. Finally, here we need to create necessary constructors and getter and setter methods. For Hibernate, we need a noargs constructor. I am going to generate that one. Select none for parameters. So our noargs constructor is generated for our entity. And we also need to generate getter and setter methods for all fields. Let me make this window smaller so that you can see the buttons here, and click OK. So our user class is ready. Now we need to create a repository to communicate with the database for our user entity. Inside our base package, create a new package named repository. Inside this repository package, create a new Java class. Make sure its type is interface. Let's name it UserRepository. This user repository extends JPA repository, and here we need to provide the entity that this repository is going to manage, that is user, and the data type of its primary key, which is long. In this repository, I am going to create a method for finding the user by username. It will return an optional because the user with a given username may or may not be present in the database. And the method name, find user by username, and it accepts string username. Now, if you know Spring Data JPA, with only this method signature, Spring Boot is smart enough to understand what we want to achieve here. Spring will generate the select query to search for a user from the users table with the provided username. If you want to know more about this method naming convention, you can check out my other video on Spring Data JPA crash course. Here I have explained this in detail. So that's all for our user repository. Now we need to create our service. In our base package, create a new package, name this service. Inside this service package, I will create a new Java class. Let's name it user, then service. And here we need to annotate this with service annotation. Now, if we know Spring security, it requires to implement the UserDetailsService interface if you want to use database for user authentication. And here we need to implement a method, that is this load user by username. And we also need to inject our user repository here. So private final user repository and name it user repository, and add the constructor to inject it. Select the user repository field and click OK. Now in this load user by username method, I am going to query the database by username. Here I am declaring a new variable of type user. Here we have couple of options. We need to user from our model package that we have created earlier. And this user equals user repository, then call our created method find user by username and provide username as the method parameter. And if user is not present, then or else throw, then a lambda expression. Here we'll throw new username not found exception. Okay, here we do not need this throw keyword. Let's remove it. Now, if the user is found, we are going to return a new instance of user. New user. Here we need this user from Spring Security Core User Details. Here in the constructor, we need to provide the username, that is user dot get username. This user that we are getting from the database, and then we need to provide the password, user dot get password. And finally, we need to provide the authorities. For this simple project, I'm not going to go deep into the authorities and roles yet. So I'm going to give a static authority here. It will be list of, then new simple granted authority, and name the authority. Let's say it's user. And that's it. That's it for our user service. Now let's close all these tabs. I'm going to configure our security settings. Inside the base package, create a new package named config. Inside this package, create a new Java class named security config. Here, add the annotation configuration. And this is our class for doing the security configuration. Here, in this class, we will define our configuration related to security. The first, I'm going to define a bean for password encoder. Then public method, return type password encoder, name password encoder. And this returns new bcrypt password encoder. And also, let's create our security filter chain bean annotation, then public security filter chain. It accepts HTTP security, HTTP, and throws exception, and return http.build. Now here, before build, we need to do some configuration. First, I am going to disable CSRF protection. Disabling CSRF is not always recommended, but here I am disabling it because our request will eventually require a JSON web token for authentication, and with token-based auth, CSRF protection is often less critical or handled differently. And you should not disable CSRF while sessions are enabled. We will make this session stateless. My IDE is suggesting a refactor to replace this lambda with a method reference. Let's do this. Then we need to provide the authorization rules for HTTP request. Authorize HTTP request. Here, using a lambda expression, I will specify that any request matching the endpoint /API /v1 then /login should be permitted for all. We will create this login endpoint later. And any other request needs to be authenticated. Then we need to add the OAuth2 Resource Server configuration for JWT handling. OAuth2 Resource Server, here lambda expression rs arrow rs.jwt. We are going with the default customizer for now. Now set the session management. Session arrow session, then session creation policy, and its session creation policy dot stateless. So that's our initial Spring security configuration. If we start this project now, let's stop and rerun. Here we have an error right now. In the console it says security config required a bean of type, it says JWT decoder, and that could not be found. So because we have added the OAuth2 Resource Server JWT support and told Spring Security to expect JWTs, we now need to provide the JWT decoder bean to decode incoming tokens. And also, since this same application will generate tokens when a user logs in, I will also define a JWT encoder bean. For token signing and verification, we need a secret key. So inside our security config class, let's define a private field, string, and call it secret key. Now let's define the value of this secret key in our application.properties file. So opening our application.properties file from the resource directory. Inside this application.properties file, I am going to provide a property, that is security.jwt and then secret. Here we need to provide a 256-bit secret key. So let's generate it. Open the terminal. By the way, I am using terminal built-in into IntelliJ IDE Ultimate Edition. You can use your operating system's terminal or command line if you are using Windows. Here we need to run the command. I'm going to use OpenSSL, then rand. This is for generating a random key, and I want it to be base 64 encoded. and we need 256-bit long secret key. 256-bit equals to 32 bytes. So I am providing 32 here. Here is our key generated. Let's copy the key and paste it as the value for secret key in our application.properties file. Now back to security config class. To access the property from the application.properties file, we need to add annotation, value, we use the $sign, then curly brackets, and inside we provide the name of the property, which is security.jwt.secret. Now let's define the JWT decoder bean. Add bean annotation. It will be public method JWT decoder, name JWT decoder. Inside this method, first I am creating a new byte array. Let's call it secret bytes, and this equals. This will hold our secret key decoded from base 64 into bytes. And here our secret key was base 64 encoded. So we need to use base 64 dot get decoder, then decode. Here provide our secret key and get byte. After that, create a new variable of type secret key. Let's call it HMAC key. This will be new secret key spec. Here provide our secret bytes and the algorithm name, which is HS256 with HMAC is HMAC SHA-256. And finally, return a Nimbus JWT decoder with secret key, provide our HMAC key and build. I'll also define JWT decoder bean because this same application will issue the JSON web token when a user logs in. And for that, we need an encoder. So add another bean annotation, public method, returning JWT encoder, name JWT encoder. Here, we need to do the similar thing with the key. So let's copy this code snippet from the decoder method and paste it inside our JWT encoder method, and returns new Nimbus JWT encoder. In the constructor, we need to provide new instance of immutable secret, and here provide our HMAC key. So our security configuration is now set up with this JWT decoder and encoder. And now let's create a controller for authenticate the user. Inside the controller package, create a new Java class. Let's name it auth controller. Annotate this with REST controller and provide request mapping for API v1. For the login endpoint, it will be post mapping to login. It's a public method and returns a login response object. We will create this login response class in a moment. Let's name the method login. It accepts request body of type login request, and obviously we need to create this class. I'll do this in a moment. Also add the valid annotation before request body to validate the login request. Now let's create this login response and login request classes. Inside our base package, create a new package named DTO. First, let's create our login response class. New Java class, login response. This login response will have one private field, string token. We need to generate the getter and setter. Now back to the auth controller. Let's import this login response. Now let's create the login request class. Inside the DTO package, new Java class, login request. This login request will have two private fields, string username and another one is password. We need to generate the getter and setter. Select all the fields and click OK. Also, both username and password are required. So here I am going to add validation for username. Not blank with message. Username is required. And for password, it's the same. Copy this not blank annotation and paste it above password. Change the message to password is required. So let's close our login request class. Now in the auth controller, import this login request. Here inside this method, what we are going to do, that is, first of all, we are going to authenticate the user and then generate the token for the authenticated user. And finally, we'll return the token as a response. Let's do it one by one. For authenticating the user, we need to inject the authentication manager. So, declare a new private field, private final authentication manager. Name this authentication manager. And also for token generation, I will create a new service. So here for that, declare a new private field, private final. Let's say our service class name is JWT service and name it JWT service. And we need to inject this. So generate constructor, select these two fields and click OK. Now let's create this JWT service. Right now inside our service package, create a new Java class, name JWT service. Annotate this with service annotation. And here in this JWT service, we are going to generate the token. For that, first we need to inject the JWT encoder. So private final JWT encoder and name it encoder. Add constructor to inject this. Now I am creating a method for generating the token. Public, it returns string, name generate token. It accepts user details. Here first we will prepare the JWT claims. I will create a new variable for storing the current time, instant now. This equals instant.now. Then I will declare a JWT claims set and name it claims. This equals JWT claims set dot builder. Then we need to provide the issuer of the token. Let's say it's my name, Iftekhar. Then provide the time when it is issued. Dot issued at, and this is now. And then when the token will expire. Expire set. This will be the current time now plus I want this token to expire after 15 minutes. So duration dot of minutes and here provide 15. Then we need to provide a subject. The subject will be the username of the authenticated user. So user details dot get username. And finally build. And also we need to define a JWS header. This header is crucial because it contains metadata about the signature itself. Most importantly, it includes a parameter typically named ALG for algorithm, which explicitly states the algorithm used to sign the token. So JWS header and header, this equals JWS header dot with, here provide our signature algorithm. This is MAC algorithm dot HS256 and dot build. And finally return the encoded token. And here we'll use our injected JWT encoder. Let's rename this to JWT encoder. Now we need to update the constructor. Let's remove this whole constructor and generate this constructor again. Select this JWT encoder and click OK. Now return JWT encoder dot encode. Here in the method parameter provide JWT encoder parameters dot from. Here pass our header and claims. And finally get the token value. And with that our generate token method is ready. So back to the auth controller. Import this JWT service. Here it's showing an error under authentication manager. Let's see. Could not auto wire, no bin of authentication manager type found. Okay, we need to define this bin. I will define it in our security config class. Open our security config. Inside this class, I am going to define that bin. Bin annotation, public method, authentication manager, name authentication manager. It accepts authentication configuration. Let's say the name is CFG. It throws exception and returns CFG dot get authentication manager. Now back to the auth controller. With that our error is gone. Now inside this login method First, I'm going to authenticate the user. So authentication, make sure it's from Spring Framework security.core. Name this auth and this equals authentication manager dot authenticate. This authenticate method accepts authentication object, typically a username password authentication token. Here we need to provide the principal and credentials. The principal is login request dot get username and the credentials login request dot get password. After authenticating the user, we are going to generate the token string token and this equals JWT-service dot then call our generate token method and provide the authenticated user's information auth dot get principal. Here we need to cast this with user details and finally return the response. Return new login response and provide the token as constructor parameter. The error. Okay, let's check the login response class. Here I forgot to add constructor that accepts the token in login response. Let's generate one. Select this token and click OK. Now let's start the project. Here in the console you can see Spring Data JPA has created a new table user with the necessary columns that we defined in our user entity. But currently, let's open our database tool. We need to refresh this. Here we have the table. This is our user table that's just created. Let's view the data. Currently, this user table is empty. So without a user, we are not able to log in. Let's see the demo user so that I can show you how to log in into the application. For this, I am opening our main application class, Spring JWT demo application. This class contains our main method. Here, for now, I am going to add a bin. Again, this is not a best practice for production data. I am just adding it here for demonstration purpose. And this will be a command line runner bin. Let's name this method command line runner. This command line runner is an interface provided by Spring Framework that can be used to run specific code when the application starts. Here, this command line runner bin method can accept dependencies we need. Here we need UserRepository, let's call it repository, and password encoder. And this returns arguments as a lambda expression. Here we'll create a new user. This is from our model. User equals new user and set the username. User.set username, it's admin, and for the password, user.set password. We need to encode the password using our password encoder. So password encoder dot encode and here provide the password. And finally save the user. Repository dot save and provide user. And that's it. Now run the project. Here in the database, as we have used create drop in our application.properties file as the DDL auto property, it's actually recreated this user table again. And after creating, it's inserted this user data. Let's check this data. This is our users table. Let's refresh. Here, a new user is added with username admin and this is the hashed password. Now, let's try to get the token via Postman. Open a new tab for login, that is post request. The URL is localhost 8080/API, then v1 and login. Navigate to the body tab, select row and JSON from the drop down. Here, provide the login request as JSON object. First one is username. Provide the username as admin. Then the password, it is also admin. Now, let's send the request. So, our token is generated successfully. Now, let's try to access the protected API endpoint with this token. Copy this token. Back to the tab for the hello get request. So now, navigate to the authorization tab for the request. From auth type, select bearer token. Here, in the token field, paste the token we have copied and send a request. It's still unauthorized. Let's check what is the problem. Open the console. Nothing here. Check the token again. I think I found the error. I just missed a character when copying the token previously. That's why it was showing that error. Now let's try this one carefully. Let's log in again. A new token is generated. Copy this token. Navigate to the other tab for sending the request. Replace the previous token in the authorization header with this new token and send a request. Yeah, this time it's working. And yes, we have the response hello world. Now, instead of this hello world, let's print the name of the authenticated user. Okay? To do that, here, open our home controller. Here, this is our hello method. This can accept authentication object as parameter. Let's call it auth. And here, instead of hello world, I'm going to return hello, then concatenate auth.getName. This getName method will return the username of the authenticated user. Now restart the project again. So if we log in the user again in Postman, a new token is generated. Copy this one and in the other tab and paste this new token here. Send a request. Here you can see I am getting the message hello admin, the name of the logged in user. And there's a very straightforward process of generating a JWT using our authentication without any third-party JWT libraries. Now in this tutorial, I have used symmetric key, that is HS256, meaning one secret key is used for both generating and validating the token. But in real-world enterprise application, this is not usually the case. There, the best practice is often to generate a public-private key pair where the private key is used to generate and sign the token and the public key is used by resource server or other services to verify that token. This is more secure than this symmetric approach, and that's what we are going to learn in our next tutorial. Till then, bye bye.